All right, so this is 2.2b, and we're going to talk about rate of change today. And so we talked about this last year in AP Pre-Calc. And so when I talk about average rate of change, what do I want to think of? Algebra slope, exactly. And so if we're going to talk about average velocity, that's algebra slope of position. And so what it really is like S of t minus like S2 of t, and then S of t sub 1 over t sub 2 minus t sub 1. It's algebra slope of position. And so we sometimes call position displacement or distance. Yes, they actually mean different things, but I'm not going to get into the nitty-gritty of that today. We'll save that for a later date. But what I really want you to get into is average velocity is algebra slope of distance over time, displacement over time, position over time. Okay, and I know I'm using those interchangeably, even though they actually do have differences, but I'm not getting into it today. All right, I need to go over some vocab a little bit more. Velocity tells you two things. Velocity tells you speed, and it tells you direction. And before I get into it some more, speed is absolute value velocity. So when I talk about velocity, if I have negative velocity, that's moving two different ways kind of thing. What is the two different ways it could be?
Down or backwards.
It could be down or backwards, exactly. And if I have positive velocity, I could be moving up or forward, okay? And so velocity actually tells you both things. And a speedometer, though, that little thing on your dashboard, I don't condone this activity, though, but has anybody ever driven really fast backwards?
Colin. Yeah, I read bar all the time. Yes, actually.
Does your speedometer still work?
Yes.
Yes, it does. It gives us an absolute value of that velocity. However, if it were a velocimeter, it would be having a what? A negative on it. But it's not, it's a speedometer. All right, so now we're going to find average velocity. So I need a good reader of things or somebody that drops things off buildings. Yes, go ahead, Luke. Go ahead.
If a billiard ball is dropped from a height of 100 feet, its height s at time t is given by the position function. S is equal to negative 16 t squared plus 100. Or s is measured in feet and t is measured in seconds. Find the average velocity over each of the following time intervals.
All right, fantastic. So average velocity, again, what should I think of? Algebra slope of position. Okay, is everybody good there? So if I have the interval from 1 to 2, what I'm finding is the average velocity, so it's the algebra slope from s of 2 minus s of 1 over 2 minus 1. Okay, do you see how we were just doing algebra slope here? Cool. And so now we're going to substitute in 2. So when we substitute in 2, 2 squared is how much? 4. 4 times negative 16 is? Negative 64 plus 100 is? 36. And then minus, now I substitute in 1. So when I substitute in 1, I'd have 1 squared, which is what? 1 times negative 16 plus 100, 84. All right. And so then 2 minus 1 is what? 1. Now 36 minus 84 is what? Negative 48. And my units would be feet per second. And so my average velocity on those intervals from 1 to 2 is negative 48 feet per second. All right, so let's do it again. All right, so now I want to figure out my average velocity from 1 to 1.5. From 1 to 1.5. So now I'm going to find what? S of 1.5 minus S of 1 over 1.5 minus 1. All right. And so S of 1.5. So now I substitute in 1.5. 1.5 squared is how much? 2.25. So then 2.25 times negative 16. Let's break it down. What's 2 times 16? 32. What's a quarter of 16? 4. So we add them together, so we get negative what? 36. Plus 100 is? 64. Thank you, Mr. Nance. All right, and then minus, now what was S of 1? 84. And then it's over how much? 0.5. And so 64 minus 84 is how much? negative 20. But then if I divide by a half, I'm really multiplying by 2. And so I now have what? Negative 40. And so my average velocity over the interval 1 to 1.5 is negative 40 feet per second. Okay? All right, so again, I need to talk about a little bit of physics equations again. All right, so S of t is equal to 1/2 your gravity constant, t squared, and then plus v of 0. And so this is actually what you call initial velocity. So the velocity at which we start with. And then plus s sub 0, and we call that our initial position. And so this is how we get our position function in our motion. This is the big kicker. So instantaneous velocity is the derivative of position. Instantaneous velocity is the derivative of position. All right, we have to talk about physics a little bit more. And so when we talk about our gravity constants, and so if we use metric units, we are going to use 9.8. I know AP Physics is using 10 now, and it's disgusting. However, in my day, it was 9.809, all right, which is really 9.81. However, we're going to just use 9.8, all right? And so when we have a half of it, we get 4.9 t squared. And then if we actually use customary units, really America's basically the only one that uses customary units. We're going to use 32, and it goes into 16 for our gravity. Okay. All right, Ethan's a diver, so he's going to read for us. Thank you.
Okay. At time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. See figure 2.21. The position of the diver is given by S of t equals negative 16t squared plus 16t plus 32, where S is measured in feet and t is measured in seconds. When does the diver hit the water?
All right, fantastic. So I want to talk about this equation a little bit, and if you're in physics, this might help you out. So this 32 is actually our initial position. That's why this is 32. This is a negative 16 because it's using customary units. It's really like negative 32 divided by 2 because that's our gravity constant, all right? So that's why it's negative 16. This 16 is actually our initial velocity, and the reading didn't tell us that, but this is actually our initial velocity, and this means Ethan jumped up at a positive 16 feet per second. That's what that 16 actually means, all right? If that were negative, guess which way Ethan would be jumping? He'd be jumping straight down, which would just be crazy. All right, but I'd kind of think that's funny too. All right, but anyway, this means Ethan jumped up at a 16 feet per second rate. All right, so let's keep going. So when does Ethan, the wolf pack, hit the water? When do we actually need to find that? What is the water? Zero. What's zero? Our position is 0. So what that's doing is we need to figure out the time. That's our when. And so we need to set S of t equal to 0. And so I'm setting this negative 16t squared plus 16t plus 16t plus 32 equal to 0. And this is totally factorable. So we're going to factor it. You don't need a calculator on this one, but you might in the later on. So what can we factor out? A negative 16, that's it. And so now we're left with what? T squared, and then what?
T.
Minus t, and then minus 2. And so now we're going to F that quadratic trinomial up. And so then what do we get?
AC, so negative 2.
So now we have t
squared minus 2, or t minus 2.
t minus 2 and t plus 1. And so now I'm going to use the zero product property. So I get time equals what? 2, and time equals negative 1. Which one do I want?
Time can't be negative.
Time can't be negative. Ethan is not going backwards in time. And so we're just worried about this t equals 2. This one's called extraneous. All right. All right. So let's look at part B now.
What is the diver's velocity at impact?
All right, what's the diver's velocity at impact? So, do you see how it just says velocity? It doesn't say average velocity, does it? It just says velocity. So what are they alluding to? They're talking about what? Instantaneous velocity. So if it doesn't have the word average in front, guess what it means? Instantaneous velocity. So if it means instantaneous velocity, what do we need to take? A derivative. So let's do it. So we're going to take a derivative. So we're going to call it s prime of t, or we're going to call it v of t. AP will actually understand both. Okay, it means the same thing. So if you like it that way, great. All right, so s prime of t, which is equal to v of t. So what's my derivative of negative 16t squared? Negative 32t, and then plus 16. And what's the derivative of 32? 0, so it goes bye-bye. All right, and so what do we need to evaluate this at? Not 0, at impact. So at impact, it's time what? 2. And so Ethan's hitting the water at time 2, so now we need to find v of 2. And so now I'm going to substitute in 2. And so now I'd have 32, or negative 32 times 2, which is negative 64, plus 16, which is negative 48. And so his velocity at impact is negative 48 feet per second. Now, I might go a little further on my assessments. So I'm going to ask you for velocity, totally. However, I might ask you for speed. And so what is Ethan's speed as he's entering the water? My speed is 48 feet per second. All right. What does the negative imply? Direction. He's going which way? Down. All right. If he was going up too far, like if he was going up the whole time, that would be weird. All right. I want you to write these down, and I want to go over another one with you. All right. So after you get these, I want to go to number 45. So on this one, we're going to take a derivative. However, you see how it's a quotient. Everybody see how it's got a numerator and denominator, yeah? All right. And so what we need to do is I can't just take a derivative of the numerator and take a derivative of the denominator and just like be good with that. I can't do that. But I have a monomial on the bottom. So guess what I have to do first? I have to distribute divide. A lot of the times we have to manipulate the way it looks in order to work with it. And so f of x is going to be equal to what? What's x cubed over x squared? X. And then now what's negative 3x squared over x squared? Negative 3. And then I now have 4 over x squared. However, I really don't want to think of it that way. How do I actually want to think of it? 4x to the negative second. There we go. All right, and so that's how I rewrote it. Now I can take a derivative. How do I notate taking a derivative, Yamil?
dy dx?
No.
Oh my gosh, why is prime? I don't know, dude. Prime x. Prime x. Prime x. Going too fast.
F prime of x. All right. All right. So the derivative of f of x is f prime of x. And so then what's the derivative of x? 1. And then what's the derivative of negative 3?
0.
Why is it 0?
Because it's constant.
Because it's constant. Very good. And then what's the derivative of 4x to the negative second? What comes out front? Negative 8. Love it. And then x to the what? Negative third. However, this is my childhood, so we need to rewrite it. And so now I end up having what? 1 minus 8 over x cubed. And there we're done. All right.